Okay, let's start working through some of the problems that are on the test review. I'm not going to work them all, but I will work at least one of each kind and explain how to do the problems in order to help you understand the concepts to get ready for the test. So this is going to be part one of the review. First three problems are all pretty similar. We're given the measure of an angle in degrees and minutes and seconds, and we're asked to convert it to degrees with a decimal. It says to the 10,000th of a degree. I'm going to do problem number 2. So the angle is 120 degrees, 20 minutes, and 50 seconds. The whole key to this is to basically take the minutes and seconds part of the angle. I need to convert that to degrees. So when I do that, then I will basically have what they're asking me for. But this is going to take place in 2 steps. The first step is I need to convert the seconds into minutes. And then once I do that, I'll have a number for minutes and I'll convert that into degrees. So let's just do it. So I'm going to take the seconds parts and I need to convert that into minutes. So I'm going to use my unit fraction. I'm starting with seconds, so my units of seconds go in the bottom of my fraction. I'm trying to get to minutes, so the minutes go in the top, and then I ask myself, what's the relationship between seconds and minutes? Well, there are 60 seconds in 1 minute. Even though we're talking about at angles, we're using the same words as time, and it turns out the relationship is the same. So it's pretty easy to remember. Now I'm going to grab my calculator. I'm going to take 50 times 1 over 60, or this is really 50 divided by 60, and that equals 0.8333. I'll just leave 4 digits for now. So 50 seconds equals 0.833 minutes. I'm now going to take that minutes. What I'm saying is now 50 minutes, 20 minutes, and 50 seconds, I can now rewrite as 20.8333 minutes. Because I just determined this 50 seconds is 0.8333 minutes, right? So I've got this number here that's 20 minutes, 50 seconds. I'm taking the seconds part and I'm converting it to minutes. So now I can write it like this. Now I'm going to take this minutes number and now I want to convert it to degrees. So 20.8333 minutes. I'm going to use my unit fraction. Start with minutes. Minutes are here. I'm trying to get to degrees. There are 60 minutes and 1 degree. So now I take 20.8333 divided by 60. And since they asked me to the thousandth of a degree, I'm going to put 0.347 degrees. So in a sense, what I've done, I've now taken this 20 minutes and 50 seconds and converted it to 0.347 degrees. So therefore, if I go back here, I can now rewrite this degree as 120 0.347 degrees. All right, the next kind of problem, we have problems 4 and 5 are now, they give us a degree written with a decimal, and they want us to convert that to degrees, minutes, and seconds. I'll just do number 4. So it's 123.123 degrees. So I'm just sort of doing the reverse of the problem I just did. In a sense, I need to take this decimal part and convert that into the number of minutes and seconds. So what we do is I just take the decimal part of this number, 0.123 degrees, and I'm first going to convert that into minutes. So here's my unit fraction. I start with degrees. Degrees go on the bottom. Minutes go on the top. 60 minutes per 1 degree. So 0.123 degrees is the same as, multiply by 60, 7.38 minutes. Now what I want to do now is, I want to take the decimal part of the minutes number and now convert that into seconds. So I take 0.38 minutes, start with minutes, minutes are on the bottom, I want to get to seconds. The relationship between seconds and minutes is 60 seconds and 1 minute. So if I take 0.38 minutes and multiply by 60, that's going to convert that into seconds, and it's 22.8 seconds, which I'm going to approximate as 23 seconds. So in a sense, this 0.123 degrees ends up being 7 minutes and 23 seconds. So I can go back up here and say, therefore I can rewrite this angle as 123 degrees, 7 minutes, and 23 seconds. All right, let's do a few more. Number 6 and 7 now. They want us to find, number 6 is the complementary angle, and number 7 is the supplementary angle. Now the original angle they give us an angle in in degrees and minutes and seconds. So let's do we'll just do number 6, because number 6 and 7 are the same except one's a complementary and one's a supplementary. So the original angle, so this is number 6, the angle they give us is 77 degrees, 47 minutes, 25 seconds. And now they're saying, what is the complementary angle? The way you find a complementary angle is you just take 90 degrees minus the original angle. Now the tricky thing here is, my original angle is written in degrees, minutes, and seconds, and there's not an easy way to take 90 degrees minus that. But what we do, and I showed you this in class, I'm not going to show you how to derive it again, but basically we can rewrite 90 degrees as 89 degrees, 59 minutes, and 60 seconds. So now 90 minus my angle is going to be 89 degrees, 59 seconds, or 59 minutes, 60 seconds minus, so here's my angle, my original angle, 77 degrees, 47 minutes, 25 seconds. So now you just subtract each part. In other words, 89 degrees minus 77 degrees is 12 degrees. 59 minutes minus 47 minutes is 12 minutes. And 60 seconds minus 25 seconds is 35 seconds. So this is our complementary angle. So for problem 7, you do the same thing, except you're looking for a supplementary angle, which means you're going to take 180 degrees minus the angle. So for the supplementary problem, we're going to rewrite 180 degrees as 179 degrees, 59 minutes, and 60 seconds. So it's very much the same kind of problem. Now if I look at 8 and 9, now we're talking about converting angles in radians, in degrees to radians. Let's just do number 8. And instructions also say, leave the answer as a fraction, do not change to a decimal. So we're going to get what they call an exact answer. We're not going to convert it to a decimal. So basically the problem is 126 degrees equals how many radians? All right, this is not a difficult problem. We just convert using our unit fraction. 126 degrees. I start with degrees, so degrees go on the bottom. I'm trying to get to radians. So radians go on the top. And now, of course, you have to remember the relationship between degrees and radians. And the one we like to use the most is pi radians equals 180 degrees. Now, since they don't want a decimal answer, I'm not going to grab my calculator, but I'm going to try and see if I can reduce these numbers. So now this becomes a problem of just reducing the fraction 126 over 180. Easiest thing is if I divide it by 2, that becomes 63 over 90 times pi. And then I notice there's a common factor of 9. So if I divide the top and the bottom by 9, I have 7/10 pi, and then I can't reduce anymore. So my final answer would be 7/10 pi. So 126 degrees equals 7/10 times pi radians. And number 9 is just like that. Now, numbers 10 through 12, we go the opposite direction. Now they give us some angles in radians, and they want us to convert it to degrees. I'll just do number 10, because once again, they're all done the same way. So number 10, our angle is 2 pi over 3. And we need to see how many degrees that angle would be. So we're going to use our unit fraction again. 2 pi over 3, normally you don't write radians, but just to make it very obvious, I'll put a radians in here. Here's my unit fraction. Radians I start with, so radians go on the bottom. On the top will be degrees. Once again, the relationship is 180 degrees equals pi radians. Now in this case, the pi's cancel out along with the units. So I have 2 times 180 over 3. Now if I do a little shortcut math in my head, 180 over 3 is 60. So 60 times 2, this thing breaks out nice and ends up being 120 degrees. All right, so it's not too difficult. Let's go ahead and finish out. We're going to have a few more problems that deal with angles. Number 13 is probably like the last one. And it says convert 4.7 degrees to degrees, minutes, seconds. So they give me an angle written as a decimal in degrees, and they want to know what this would equal in degrees, minutes, seconds. What we do here is, actually when I look at this, problems 4 and 5, I'm trying to make sure are the identical kind of problem. So I think I might have repeated, because what you do is you just take the decimal part in degrees and you convert that into minutes and then seconds and then have the answer. So I guess 13 is really a repeat of 4 and 5. That was a little bit of an oversight, but I just realized that now. All right, so let's take a break, and I'll stop now, and we'll then continue on with another video.